proving some stuff today. So the way these go, we're proving we're establishing identities like this one we have here that we'll do right now. And the first thing you might just kind of do is process what is even being claimed. And the thing that's being claimed is that this side of the expression equals this side of the expression, no matter what theta is, provided that it's defined for both expressions. So for example, if you plug in pi over 6 to both sides, theoretically, if this is true, then you should get the same value from both sides, or any other angle. If you plug in, whatever, negative 2 pi over 3, you'll get the same answer from both sides. How else can we conceptualize that? If you plug in this into your calculator in y1, and this into your calculator in y2, and graph them, those two graphs will land on top of each other exactly. Or if you go to the table, all the y values will agree for every single x value for which they're both defined. All right, so I want to make sure you're understanding what this is claiming. This is not an equation to be solved. The claim here is that every value works. The solution to this is all reals, or at least, again, all reals for which it's defined. Okay, so how do we go about proving these? Well, I think I've told you enough times now on your papers as I've graded them. I said, do not assume the thing you're trying to prove, right? So we're definitely not going to work with this equality at any point, because it's not been established as an equality yet. So what we're going to do is take one side and work with it alone and manipulate it until we get the other side. Now, it's your free choice as to which side you want to work with. But I don't know. Do you have an opinion here? You want to start with the left or the right side?
The left.
All right, that sounds great. But I'm not sure that either one matters too much in this case. I'm going to use LHS and RHS for, what are you going to go stand for?
Oh.
Left-hand side is secant. It's just a convention that will be, I think you could guess, yeah.
Intuition.
Good job, yeah. So now we just, let's start by going by our gut feeling here. What, after having some experience of applying these expressions, what is your irresistible urge on this particular expression? What would you like to do? Well, what thing would you like to replace with what thing? Go ahead, Jay. Pull it apart. Okay, factor that out. Okay. Or what else could we do, Brandon? It equals tan. Tan squared. I'm going to favor that one only because I kind of went down in my head the road where Jay was going, and I didn't see any fruit. Right? Like, I mean, yes, you could factor that. Secant minus 1, secant plus 1. But I was like, then what? I could kind of play that forward in my head. But I will say that as you're doing these tonight, in homework 2, you should have an eraser right by your side, because you will make missteps along the way. So things might look clean in class, but you're going to go home and be like, well, how do I keep messing up? Well, you will. That's just how these work. You just do something, you're like, that wasn't very fruitful. For instance, have an eraser at the ready. Don't do these in pen, Jay. Okay? That was one time, but you'll never be forgotten. Okay. You should have seen this quiz, you guys. I mean, really. Okay. All right. All right. So, huh? That would have been better. Yeah. No, he was in pen though, all over the place, scratchy stuff. All right. We need another insight. Jasmine, give us. It is true that tangent squared is sine squared over cosine squared. Is that what you're going to say, people over here? Okay. That's true. And I also kind of like that idea, and the reason I think that's a strong choice is because I see that in the target expression, kind of looking ahead here, I do see that there's just not a tangent in that. So it makes sense too, from that perspective, to maybe get rid of the tangent if we can make that go away. How should we deal with that expression now? Yeah, algebra, how do we do this? Yeah, and then those signs will cancel. We'll get, in fact, I think, don't you see this all the way home now? So the signs cancel, leaving a sine up top and a cosine squared on the bottom. Come on now. And now this is where this stops feeling in any form. This doesn't feel like simplification anymore. This is really us the whole time, but especially now, moving toward the target expression, right? This last move here is certainly, no one would say, a simplification. It's a complication or something. Okay, so let's just make sure we're clear what we've done. The left-hand side equals that, which 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 equals this, which is the right-hand side, which was what was to be demonstrated, right? So we might even write, if you want to sound fancy, you could even write QED at the end, which literally means in Latin, which was to be demonstrated.
Oh yeah, that's
right?
shirt.
And now you'll feel as smart as all those people with those QED shirts, you know, all those cool people.
You can see that on the test.
Oh wait, like this person right here, for example, who has a QED shirt on. I didn't mean to call you out there like that, Stephanie, but yeah. Quote.
Woo!
A mathematician's way of saying "I win" is what it says. I like this shirt. It's fun. But QED is in Latin, quod erat demonstrandum, which means which was to be demonstrated, which is grammatically a correct way to end this sentence, right? The left-hand side equals this, which equals this, which equals this, which equals the right-hand side, which was to be demonstrated. Or sometimes people write like as desired, right? Which, well, I just mean if you want to sound smart, there are a couple options for going. You're right, like this equals this, which equals this, which was to be demonstrated, or as desired by the.
You can write LOL.
If you want to. In written, in typed papers and textbooks, you'll see sometimes this symbol, which literally means QED. This black, a little black box. Yeah, sometimes you see that at the end of a proof. It means QED as well. Okay.
What does QED stand for again?
Quote erat demonstrandum.
No, but they should have put on the shirt because it's like a black box on like a white shirt, and it's like it's so much funnier.
You can Google it. I'm probably saying it wrong. All right, so let's do another one. This is so much fun. Let's do one.
Oh, I learned to like 87 on the homework.
All right, so we need an idea. Size to start on here. What would you like us to do?
Let's do the right hand side. Right side. You do the left side.
Okay, fine with me. Right hand side. Okay. RHS. It doesn't look very much like that. All right, and now I need an idea. By the way, before we even start proving this, we should sometimes just stop and step back and forget the proof for a second and just appreciate the fact that if this is true, that's really something really interesting and beautiful. That like tan squared minus sine squared is the same thing as if you take the tangent squared and multiply by sine squared at any angle. That's really, if this is true, that's really quite amazing. We just step back for a second and look at it. We're like, that's, how could that be that tan squared minus sine squared is the same thing as tan squared times sine squared? Well, apparently it is, and we're about to prove it, so I don't know. All right. So some of these are kind of interesting. They're just even the look of them is like, huh, that's really cool. All right, that buy you any time? Do you have any thoughts? Keep in mind where we're going too. I don't know what would you like to do. You have an idea? Someone? You got to at least get a good start on this. I don't know. What would you like to do? Is that a hand?
I don't know. This might be like a little on the complicated side.
I'm okay with that.
But to put them both in terms of cosine, you could do like sine squared theta is equal to 1 minus cosine squared theta, and then tan squared theta is equal to secant squared theta minus 1. So or 1 over.
Is it okay if I take you up on one of those,
Yeah.
but not both?
Yeah.
Yeah.
I'll allow it. Oh, that's very just as good.
Wait. What? Oh, I see.
Go ahead and finish it.
Bro, that's crazy.
Oh, no. Don't give it away to anyone. Let everyone finish it. Go ahead. Multiply it out. Yeah, we want to let everyone enjoy this experience. So. I will say we probably chose the wrong side. This is the harder direction I think to go probably with this one.
Good, it's good practice.
But it's good. No,
Would they like?
Then you can just switch around with the left side one.
Exactly. Yeah. No. It's just so happens. No, there's no.
I'm so enlightened by this.
All right. So what do we get here? We get well, and actually, maybe before we multiply it, you could even write this as, just to make it obvious, this is 1 over cosine squared minus 1 times sine squared. So maybe now it's more obvious. We get sine squared over cosine squared minus sine squared. And we have now the left side, right? As desired.
I feel like I can solve like the secret of the universe.
I feel like you can too. There you go. If you want me
Oh, I
to.
gotta get that one. You play.
Yeah, can you see, if you want to see what the proof would feel like, having started with the left-hand side, it's quite easy to see what that would look like. Just read it backwards, right? If we had started with the left-hand side, the proof would have felt like this. Consider the left side. Let's replace tangent squared by this. That would be a thing you would try. Let's factor out a sine squared. Isn't this the kind of thoughts you would be having if you were doing this backwards?
Oh, yeah.
All right, and then this is that. Oh, well, that's this. And that might have been a slightly more natural way of reasoning through it, but this is a good demonstration of the fact that it might be harder one way than the other, but in the end, theoretically, both should work just fine either way. You know?
So that could that be like as a check for us if we would go back? And
Sure,
forth?
yeah, I would, of course, want to look it over. You can look it over from front to back to front, and make sure it makes sense logically in every direction, yeah.
So is this the thing that we're doing in class? Tangent squared theta minus sine squared theta is the same thing as the two things multiplied?
Yeah.
Is that something that like we should know like off the top of our head?
No.
Is that just like a random?
I don't think that's ever really going to be useful to you necessarily.
But maybe one day.
Maybe one day. It's just for fun, really. Yeah. Like this one, I don't think you'll ever need to know the fact that those are equal, but it's fun, right? It's interesting.
Let's do more examples of that.
Which one?
The one that we just did, yeah.
So as we've been doing this, I have a couple tips I'm going to put up here in a second. I think there have been some things we've already picked up, even having done 2 examples in terms of like kind of tips we would give someone in doing these. One is if there is a more difficult side. Can I go there now?
Yeah.
Okay. One is if there's a more difficult side, begin with it. If there isn't, then whatever, just throw the coin.
Flip a coin during a test.
Right. If there's a more complicated side, start with it. That is, say we're trying to prove that this expression equals tan x. What I don't recommend is starting with the right-hand side, right? Be like, well, tan x equals, and then complicate tan, you know? So you want to work with maybe this expression, and guess what? Where's the proof of this? Right here, right? This is the proof. Done. We're done. We have been doing proofs, and in some ways, I want you to understand that really, as we're doing proofs, you might be thinking, oh, I've heard about this. I'm terrified. No, in some ways, though, really, it's like the same thing we did last night, except with an answer key built in. It's like, by the way, work with this expression. By the way, here's what you should get, please. Right? So that's right. Please. Right? It's not exactly simplification as we saw in a previous one. And in fact, I want to highlight this one right here now, too, down here at the second to last. Keep the target expression in mind. You saw us doing that on the first example today, right? We were doing simplification a lot of times. That's kind of how we're motivated. But really, the big thing we're doing is we're trying to manipulate the expression toward whatever our goal is.
Wait, so we start with the difficult side?
Yeah, start with, if there's a more complicated side, maybe start with that and reduce it to the simpler side. Because it's going to be hard to take a simpler side and make it more complicated. Though it's not impossible.
Make a complicated side.
Yeah. You saw us already do this. Didn't we do that on the first one, I think, too, right? We kind of bailed and said, like, well, let's just write it in terms of sines and cosines. Kind of reminds me of, like, kind of the chess player's advice. When in doubt, move a pawn if you don't have any other better idea what to do. Just change everything to sines and cosines, right? It's not exactly declaring bankruptcy, but it's just like, I don't know, maybe it'll look simpler if I just have it all in terms of sines and cosines instead of 6 different trig functions. Combined fractions, that was fruitful in today's warm-up, right? Like, in fact, if you tried to do today's warm-up and you would have been like, unless you tried combining fractions, you just didn't have anything to do. And there's a lot of combining fractions that happen in the homework class now, too, right? You're adding fractions together, maybe.
Oh, crap.
And that's often fruitful. All right, so I've talked about most of these here. This one is an interesting one, and you've already probably seen. Yesterday we saw this happen with the last example in class, where we were doing secant squared minus 1, and you saw that oftentimes these different Pythagorean identities can be factored as differences of squares. So if those things happen, take advantage of those situations, or possibly even create those situations for yourself. If you see one of the two, a plus b or a minus b, multiplied by the other to create that situation for yourself. Whatever. So, yeah. So that turns out to be useful enough that it makes this list. It turns out that that'll come up now and multiple times, just mainly because we really like the Pythagorean identities. So you should be on the lookout for differences of squares. They'll just turn out to be quite useful to you. And then the last one I say, of course, with great caution, the one at the very bottom, because I want to make sure this is still very firm in your mind that you may not work across the equal sign. There's never a time when I'm going to allow that, because that's you begging the question, right? You're not allowed to assume the thing that's true. But what you can do is take one expression and put it in its own dark room, and the other expression and put it into its own dark room with a very, very thick wall separating them, and work on them both separately if you really need to, and then see that they're equal. That's fine. That's fine. As long as, but what you can't do is like multiply both sides by side. No, because that's you assuming that the thing we have is already true. Okay. So, but I would probably avoid this unless absolutely necessary. Yeah.
Isn't it like mathematically incorrect to like assume both of them are equal? Like, is there ever a time that like we assume both of them are equal, and like
Sure.
I guess
negative 1 equals 1. Therefore, 1 equals 1 because I squared both sides. Therefore, the original thing is true. Yeah, exactly. Okay. You could have an incorrect statement that you could make something true out of by using algebra. Yeah. All right, let's try another one. Keep in mind the tips. Tips and tricks.
Why are you giving them ideas?
That's great.
No.
No, like for next year, not for this year. Next year, They'll probably love that. They'll probably use that.
You're like a politician. Leave this for the next generation. What are you going to do first here? Which side are you working on? People who are doing something out there? Left. Sure, that's fine. In this particular case, I think you'd agree that there's really not a more difficult side. It's not like if you get stuck on one side, I think you probably get stuck on the other too. I think they're both equal. So, but the left-hand side's fine with me though. It's fine. But I'm kind of stuck.
Yeah, I'm also stuck as well.
Let's see. So pick the more difficult side. There isn't one. Change everything to sines and cosines. Already there. Okay. Oh, what other tips we got?
Combined fractions.
Combined fractions. There are no fractions to combine. All right.
Keep the target.
That was a really great list, Mr. Chase.
Oh, Pythagorean theorem. Pythagorean theorem.
Anyone have a thing that they're trying that seems to be working? It really does seem pretty intractable. Like there's nothing we can do to it.
Wait, can we multiply like?
What do you want to do, Jamu and Reggie? Multiply by 1 plus cosine? Yeah, you can't just multiply by 1 plus cosine. You can multiply by 1 plus cosine over 1 plus cosine, though, he says.
Oh, I see what you.
Okay, I think that might be not a bad idea. Can you, first of all, of course he's allowed to do that. Can you already see where this is going to go?
Yeah.
Don't ruin it for anybody. Just like Star Wars, we don't want to give away the twists. Okay? I don't want anyone telling you tomorrow what happens if you go tonight, okay?
Oh, great. When are you doing that?
I'm seeing it tomorrow night.
I'm seeing it Saturday night.
My friend had tickets to see it tonight, but then she realized our concert today.
In case I see you happen.
I don't know, work the solution is one of the math problems. Like have it like written
Well, there's
out,
supposed to
like,
be a big
variables or
twist.
something?
Finish this, please. Go ahead.
Oh my god.
Isn't it beautiful?
Yeah.
No one wants to rob this feeling from you. Take you do it.
They do
Yeah, because there's kind of two reasons. One is you'd like to see a 1 plus cosine at the bottom, so it's just kind of like wishful thinking. And then the second reason is that one of our tips was to set up different squares, right? And you know that possibly you could have diagram that numbers on that. You still see. Does it feel good? You feel right to it? Yeah, multiply it. Multiply out that numerator, right?
I feel it. Yes.
It just doesn't. The proof writes itself after this. Seeing that first move was really the 95% of the work here, right? Like seeing that first step, making that choice. What are the two motives for doing that? One is because our list suggested it, right? That like setting up differences of squares is like a thing that might yield Pythagorean identities for you. The other reason you might have been motivated to do it is just because you're like, hey, I'd like a 1 plus cosine in the bottom. Wishful thinking, you know? Like, if you want something in life, just like make it happen. You want a 1 plus cosine in the bottom, you can put one there. As long as you also put it at the top. So I think those are two strong motivations for having done what seems maybe at first to be something crazy. So you get 1 minus cosine squared up top. And on the bottom, we'll just leave this as it is. How about? How's this? Is this feeling good?
Yeah.
On top, we get sine squared. And one of the signs goes away, yielding the result, the right side.
You gotta put the fuck.
Oh, switch it up. Yeah, let's switch it up a little bit. Okay. So do you like the form of that proof? So a couple of things to note again. We're favoring expressions that target the end. We're using a plus b times a minus b to set up applications of the Pythagorean identities. What else do we do? Another thing, keeping in mind the end expression. I think most of us, if we saw this, you'd want to like not just multiply out the top, but maybe multiply out the bottom too. But if you do that, you're going to have to undo it a step later to factor out the sine x. So just keep in mind that I want the 1 plus cosine there. I'd like that. So I don't need to muddy the waters. I can just keep it not multiplied out. Actually turns out to be a good move.
Oh, right.
Oh, I don't know which side. Which side are we starting with here?
The right side.
It looks maybe more complicated, but you really could go either way here. I don't know. I could be. No, I'm actually being serious. You could go either way on this.
Oh, that's a 5. I don't do this. Bless you. That's my biggest pet peeve. What? People sneeze money on purpose.
All right. So again, think about things that immediately strike you, but also favor manipulations that get us closer to the target expression on the left. What do you have an irresistible urge to do with the expression that's currently on the board?
Distribute.
I don't think I want to distribute, actually. Yeah, I think I want to get closer to this form, which is not an additive expression, it's like a multiplicative expression, you know? So, yeah, if we can we, is there any obvious factoring that can be done? Yeah, take out a something. Yeah, we can take out a cosine squared, which is a beautiful thing. Let's see, 1 minus. If we take out a cosine squared, that leaves us with 2 less powers of cosine all the way there. Is it okay if I take out the cosine squared and put it way down here? Is that okay? Why did I do that? Really, it's just for cosmetic reasons. Yeah, just because it kind of looks like the left-hand side, and I want to continually convince myself that that's where I'm headed. So, in fact, that gives me a little bit of a goal in mind, too. It means that what would I really like to be able to say this is? This whole thing in parentheses. Yeah, I'd like it to be sine to the 4th, right? So that this is all sine, right? It's like we're almost done if this was sine to the 4th. So that would be, that's like our new little mini proof here. Let's see if we can get there. Yeah, that's true. Stuff in the parentheses is messing with me though. Okay, so I want you to stare at it for a second. Don't tell anyone what you're doing. But in a second, I'd like someone to just give us a hint. If you have it, don't give it away. Just give us a hint. You have a hint? What? A T substitution. Is that like a thing? Why not U?
I don't know.
Why not M?
What is I
T.
mean, like,
I'll do whatever you say. Okay, T. T substitution for what? All right. So yeah, you're saying. So let's think about that expression in terms of like instead of cosine T. So like that or something. Like maybe you know how to factor that. She's saying. Okay. I think factoring is a strong idea, and thinking about that expression on the board in the bubble is a strong idea. Let's come back to that in a minute once people have thought about this here.
I think
Our goal is to factor. Here, factor that expression.
okay.
Do this over here first. If you want.
Oh my God, wait.
Well, in the interest of time, how does it factor? Yeah, 1 minus cosine squared. Squared. It's a perfect square we're actually looking at, someone says. All right, well now the rest is, that was the big move on this one. So that's sine squared. And we still have this stuff hanging on the right. So that's sine to the 4th, which is what we wanted to show. And finally, we have the left-hand side.
A masterpiece.
All right, so that's our proof of that. So homework 2 is going to be for tonight. Let me make sure I say one thing before you leave here too. I will not be here tomorrow. What? You will be assigned homework 4 tomorrow night, and when the sub says that to you, just don't be surprised. We're going to do homework 3 on Monday night, okay?
Is it special?
Homework 3 is like more proofs, and they get really hard. And I want to be here to hold your hand. So we'll just switch those two. It'll be no big deal. Okay.
I want to make sure that we're like safe and we're not.
Yes, I tend to like my block. I just want to make sure that no one is eaten by a wolf. So homework 1 tonight, or homework 2 tonight, please.